Hey guys, I'm Will from Tested. We are here at Johnson Space Center in Houston at the Space Food Systems Laboratory. I'm here with Vicki Claris, who's basically in charge of everything that the astronauts eat on the space station.
Well, at least US provided food on the space station.
Okay.
We do have our Russian colleagues who are providing about half of the food that goes to the space station.
And they're separate but equal in the...
Separate but equal, but they do share.
Okay.
So there's a lot of food sharing that goes on.
So we'll talk about the food on the ISS now in a minute, but let's talk about a little bit of the history of space food first, because this is really interesting, and in order to appreciate what they're eating today, you have to really see where it came from and how it's evolved over the last 50 years.
It's evolved quite a bit. So when we started out talking Mercury and Gemini, the very early US missions, it was cubes and tubes.
Wow.
And this is what most people think about when they think about space food, is that they think we're still in the cubes and the tubes era.
So they would squeeze out a paste of, this is bananas?
Yeah, this just happens to be bananas.
Okay, that sounds fantastic.
Yeah, so it's basically like baby food. It was pureed, and they would just squeeze it into their mouths.
Wow.
And they had to actually put a little adapter on this tube because they would do this wearing a helmet, and so it had to be long enough to reach to their mouths inside the helmet.
And so the astronauts, were they keen on this food, or?
Well, yeah, you know, it provided the nutrition that they needed, but it certainly wasn't very aesthetically pleasing.
Okay.
The cubes were all dried products like cereals and dried fruits and things like that. They were coated with an edible film because they were very concerned about crumbs getting loose in the cabin.
Oh, okay.
So basically they were coated with a starch that would dissolve when you put it in your mouth. And so the cubes, they just cut them open, popped them in the mouth. So it did provide the nutrition they needed, but you know.
So how many of these cubes and how much of a tube would they have to eat to get a day's, the food that they needed to survive?
A lot.
Okay.
But you have to remember those early missions were very short. Some of them were even less than a day. So,
so they were looking for snacks, not meals.
Yeah. Then we went into the Apollo era and we added more of the freeze-dried, and we actually packaged it in what we call the spoon bowl so that they could actually use a utensil for the first time.
Oh, okay. So
they rehydrated this product, opened up the spoon bowl package, and were able to use the spoon to eat.
So at least the act of eating is more normal.
More normal. And then as we went into between Apollo and Shuttle, we had our first space station, which was
three missions to Skylab.
Yeah. And actually Skylab was the most sophisticated food system that NASA's ever flown.
Even more than today?
Yes, because it included some frozen food.
Oh, wow.
Which is the one and only time we've had freezers dedicated to food on orbit. And so they had a rather elaborate dining tray for Skylab because it also served as the oven. These front three wells were controlled by the switches on the front.
Oh, so they had a heating element in there.
And so they had a heating element embedded in here to heat their frozen food items.
So they took stuff out of the freezer, put it in the tray, flipped it on, came back an hour or so later, and had a piping hot meal.
And they were ready to eat, yes.
Wow, that's fascinating.
So as we went into the shuttle era, unfortunately, we went back to an all shelf-stable food system.
And when you say shelf-stable, you mean that it
no
doesn't have to be
refrigerators,
refrigerated?
no freezers.
Okay.
Everything has to last a long time at ambient. So what we had was this meal tray. They would Velcro this actually to their thigh, and that created a tabletop for them to eat off of.
Wow.
And so the silverware was magnetic and would stick to the tray. We had Velcro on all, still do have Velcro on all the packages so that it could be stuck to the tray.
Okay.
And then a spring to hold small things like condiment packages and things like that.
Things that don't have a stick of Velcro on them. So there's, what is this guy right here? I've not seen this before.
Okay, this is the straw that's used to drink the beverages. So early on we used this package. They would rehydrate. If it was a beverage, they would insert this straw through the septum, and that's how they drank.
Okay.
And it's got a clamp on there so that in between sips, they can clamp it closed to prevent the fluid from flowing out of the package in microgravity.
What happens if they don't clamp it closed?
Okay, if you leave it open, it won't happen quickly, but gradually you'll have fluid migrate up the straw and begin to form a big ball on the end of the straw.
Without having to squeeze the bottle or anything?
If you just leave it there, it'll happen. And so that can get really messy.
I can imagine.
And so the crew members learn pretty quickly that what they do between sips is they clamp it closed, and then they make one last draw on the straw to be sure they get the last fluid out of there.
Got it.
Because if you hit this, and there's still fluid in there, it'll go and it'll make a mess.
Fling
It'll
your
get
apple
on
juice or
you,
coffee
or it'll
or-
get wherever. So beginning in probably the mid to late 90s, this is how we fly our beverages now, and this is how we fly our freeze-dried foods
So this
now.
is the most modern packaging that we have
This is the current
available.
packaging that they're using on the space station.
And it uses the same straw. It looks like you put the same straw just straight in the top.
Yeah, the septum, instead of being in the corner of that rigid package, is now located inside this, what we call a septum adapter, that holds it in place. And so they rehydrate the same way with the needle, and then they just insert the straw through the septum, and they can sip out of this package.
Fantastic.
And so this is actually the same material that the Capri Sun is marketed in. And so we buy it from the people who make it for Capri Sun. And when we get it, it's sealed on 3 sides. It's open on this end. So we weigh in the amount of beverage powder for a single serving. And then we have a custom piece of packaging equipment that seals this adapter
just
into
cinches
the
it down
end of
and
the
vacuums
package.
the
And
stuff
vacuum
out.
seals it.
Fantastic.
And then we add the label and the Velcroing and stuff like that.
So everything has a barcode.
Yes.
But do you track everything that each astronaut is eating at every meal? Or is it?
No, not necessarily. The only time we do that is if they're participating in an experiment that requires them to do that. And if they were, that would only be for certain days of their flight. It would not be for the whole 6 months.
So for
that
3
they're
or 4
up
days
there.
at a time, not 3 months at a go.
Right.
It would be a little tedious, I think.
And so we do have the barcodes available. So if they need to track, they have a barcode reader and they can scan it, and that'll keep them from having to write down anything.
So there's a couple of different ways that food's prepared to go to the station these days, right?
Well, there's a couple of major processing methods that we use. Freeze drying is one of them. And so with the freeze dried products, we package it like this, and then they're going to add back water. We call them rehydratable, meaning they have to have water added prior to consumption. Mostly it's freeze dried, but we also do some commercial products in here like cereal and non-fat dry milk. So they would, add the water on orbit, and that's how they'd get their cereal and milk.
So on the cereal and milk, you don't make the cereal and then freeze dry it.
No,
you
no,
just add the milk powder to the cereal.
It's a natural form product. It flies, exactly as it is from the manufacturer. We just package it with the non-fat dry milk, and they add the water on orbit.
So then on the label, it also has the instructions to prepare, and it tells you how much water to add, whether to add hot or ambient, and how long to let it sit afterwards, right?
About how long it's going to take for it to rehydrate,
You also have the retort food, which we talked about with the shuttle a little bit, but it's interesting because I don't think a lot of people know how this is made.
This is called thermostabilized, meaning it's been made stable by heat. And this is just like your canned products that you have in your pantry at home, except it's been done in a pouch. It's called a flexible can, or it's called a retort pouch. And retort is the piece of equipment that you use to manufacture these products.
So then the process just heats it up to a really high temperature, and then it's safe to leave on the shelf for a long time?
Yeah, though it's really the canning process like your grandmother or great-grandmother did.
I can.
Okay, well, you're in the minority.
We're special, I know.
Yeah, you're in the minority. But so basically the product is produced, it's sealed in the pouch or in the can, and then it goes into the retort, and the retort uses a combination of heat and a little bit of pressure to kill the bacteria inside. And so what you end up with is a product that they call commercially sterile.
So you guys, you prepare a fair amount of food here, and you also buy commercial food where it's available, right?
We do use quite a bit of commercial off-the-shelf products. We call them natural form products, so all we do is repackage. And a lot of people ask, why do you bother to repackage? Well, there's multiple reasons. One is that every material that goes inside a spacecraft in any quantity at all, any significant quantity, has to be tested. You're looking at flammability, you're looking at off-gassing, what chemicals it might give off. So rather than trying to test all the different manufacturers' packages and then having to retest them if they change anything, it's more cost effective to put them in a standard material that's already been.
Got it.
So this has been off-gas, the ink on the label, the adhesive, everything's been tested to make sure that it's fine for a closed spacecraft
All
environment.
the way down to the Velcro dots.
Yeah, absolutely.
I've also noticed that a fair amount of this has both English and Russian labels.
So before there was an International Space Station, we flew food to the Mir space station. And one of the agreements we made with the Russians is that we would put Cyrillic labeling on there so that it would be easy for their crew members to identify what the product was. And so we've just continued to do that, even though now really it's probably not necessary anymore because with the amount of training back and forth that crew members are doing, most of our most of the cosmonauts are able to read the English by the time they get to orbit
and
anyway.
They're familiar with it after a few weeks in on
So,
orbit,
but we still have it on the label.
So then how do you manage, or do you manage, like astronauts' caloric intake?
Unless they're participating in a medical experiment, they're not going to be tracking exactly what they eat every day, so we don't get that data.
Okay.
But on the medical side of the house, our nutrition research lab, they do have what's called a food frequency questionnaire.
Okay.
And so it's on the computer, and about once a week, the crew members go on there, and they make basically estimates of how many servings from each category they have consumed during that week.
And the categories are things like meats and vegetables and snacks.
Well, and we're also looking at like sources of salt and sources of calcium and things like that. So they're using it to track calories. They're using it to track moisture, water intake, but they're also using it to track some key macronutrients as well.
Okay, and so it has to do with things like bone loss and muscle density and things like that, right?
And then they also have what they call a mass measuring device on orbit, so they can actually get their relative body weight. So they can tell if they're losing or gaining. And so that we don't get that data, but the flight doctors get that data.
So a normal scale wouldn't work in microgravity.
Nope.
How does the mass measuring device work?
It works on displacement. So it's kind of like a pendulum. They actually sit in the thing, and then based on how much they displace back and forth, they can calculate their weight.
Wow, that's amazing.
Yeah. And so the combination of that and the food frequency questionnaire, if they see a crew member losing weight, they can say, look at the food frequency and say, okay, you're not consuming enough calories, or you're not getting enough protein, or, so they can use those two things together to at least get a high level knowledge of what they're eating, even though it's not specific.
So there's no surprises when they come back to Earth. And
right.
We don't want anybody to lose 20 pounds when they go up and they're already very fit.
Yeah.
So there's one thing you mentioned at the very beginning is that the Russian side and the European side don't eat the same food.
Our Russian colleagues provide about half of the food that goes to the International Space Station. They still use, in thermostabilized, instead of pouches, they're still using cans.
Wow.
And they come in a couple of sizes. They have small ones, and then they have some that are a little bigger than this for entrees. So these are basically like side dishes in this size. And they're not even, they have to use a can opener to open these. They're not even flip top.
Wow.
So they have, in the Russian segment, they have a table in the service module, and it actually has warmers, little slots built into the table where they drop these in and they're warmed by contact.
Oh, okay.
Yeah. For our pouches, the pouches, obviously, with the cans, the slots this size, they don't fit so well in there. So we had to come up with a way for them to warm the pouches. And what we did was, early on the shuttle program, there was not an oven or a galley on board for the first few shuttle flights.
So they were just eating cold food?
No, actually they had what we called a suitcase food warmer. It was like a metal briefcase. And so you open it up, and there's a hot plate in there, and you line up the stuff on the side of the hot plate, close it up, plug it in, and it warms it up.
Wow.
And so when we started sending pouches to Mir and to Space Station, the engineering folks basically went back and resurrected that suitcase food warmer, made it compatible with station power, and so that's what they're using to warm the pouches on orbit.
So we've talked about the food, how you guys prepare it, how they prepare it on orbit, and then there's another pack over here, and this is all super familiar to anybody who eats at any kind of fast food restaurants. You guys ship packets of condiments up
Yes,
for
we
them.
do. We kind of have a standard set that we send, so mustard, mayo, ketchup, those kind of things. But then they can also ask if there's a particular hot sauce or something they want.
Sriracha or Texas Sunshine or whatever.
We can send it as long as we can get it in either a squeeze bottle or not glass. We can't send glass to orbit.
Okay.
But yeah, we've sent just countless different kinds of hot sauce and salsa and things like that to orbit over the years.
Is there just a bag full of leftover condiments on the space station someplace? Or,
well, no, we kind of have to tell them when to throw it away.
Oh, okay, very
Because
good.
otherwise they might let it hang around
hoard.
too long. Yes.
Very good. But there's no salt and pepper in here.
No, because you can't use the solid version in microgravity.
Oh, because it would make a huge mess.
It would, and it would get in your eyes potentially. So we actually send salt and pepper in liquid form.
Oh, wow.
So the salt is dissolved in water, the pepper is dissolved in a food grade oil, similar to a cooking oil.
Okay.
So it's in a squeeze bottle. They would just open it up, squeeze a drop, and they have to touch it to the food and then stir it in.
Wow.
If they want to use salt and
So
pepper.
it's like a pepper infused oil,
Right,
basically.
yes,
It's
it
really
is.
neat. Well, thank you so much, Vicki. I think we're going to go taste some food now, right?
Yep, we sure are.
Fantastic. So let's grab Norm and go into the lab.
All right, Vicki, so you've brought out some heated up food, and this is a selection of out of the several hundred food items that you prepare here. So let's go and try it. This is just apple cider, and the package you had to hydrate this.
Right. On orbit, they would use a needle at the rehydration station to inject the water, and then you're going to have to squeeze a little bit, but there you go.
It's like apple juice, and this is
Yeah.
ambient temperature, totally good apple juice. Now, you explained to Will earlier that this is basically like canned food. And there's like an MRE, there's tear marks, and you've heated this one, so it's nice and warm, and it's just tear and...
Well, actually, what we recommend to our crew members on orbit, because they're in microgravity, we actually recommend that they cut across here. And the reason we recommend that is because in microgravity, then they're gonna eat out of here with a fork or a spoon, depending on the product. And by going in this way rather than this way, you keep your hands cleaner because you don't have to reach down as far inside the package.
Got it. All right, I'm gonna try the tomato soup. It's a little difficult to spoon out of here.
Yeah, they can make it bigger if they want to. They quickly figure out how
There's
to.
chunks of tomatoes in here.
Yeah.
Yeah, it tastes like pretty good tomato basil soup. And this is a barbecue beef brisket because we're in Texas.
Right.
We tried
Gotta try the
barbecue,
brisket.
local barbecue, and the local barbecue here, it turns out, goes to space as well. So this is brisket. Wow, it looks like brisket, but it looks pretty tender. All right. I enjoy this. This is quite good. All right, let's move on to the next couple items. Now,
Okay, these are examples of our rehydratable items. So in this case, they inject water just like they did into the beverage, and they're going to wait for the product to rehydrate. And then typically on orbit, what they'll do is they'll cut an X across the top of the package. So they'll
so
start
this
with
seems
a little
like
notch.
a little practice
Yeah,
would help.
they learn how to do this. And then what they're going to do is they're going to eat using their utensil out of the center of the X, and the flaps from the remaining material will help hold the rest of the product in the package as they take out a bite.
And this is a teriyaki vegetable mix. Not as good as the barbecue beef brisket. How many utensils do they have?
They have a set, so they have fork, knife, spoon, scissors, and then it's...
One set per crew member?
Yes. The way they keep them clean is with wipes. We don't want them utilizing each other's utensils, just in case one of them was sick, because it really doesn't totally sterilize them.
Share the food, not the utensils.
Yeah, right.
The grits are very buttery. I'm not the biggest fan of grits, but they're all right. And then finally, some cream spinach, and I really love cream spinach. And there it goes. That's not bad too. I like that. Yeah. So eating on space, it's kind of like eating at a high school cafeteria. Yeah.
You know, some crew members compare it to a camping trip or something like
Yes,
that.
a very long camping trip, far
on
away
space
from
station,
home.
it's a very long camping trip, yes.
Well, thank you so much, Vicki.
Well,
this
you're
is
welcome.
very educational. The food is pretty good, and we'll have more from the Johnson Space Center on Tested.com. I'm Norm. We'll see you guys. Bye.